We're going to continue with the multiplication law for independent events. We'd gone through examples 1 and 2 with the spinners. I'm just going to go through example 3 and example 4. Now, this is where they're not that much more difficult. They're not more difficult at all. It's just the wording of the question is be very careful with, okay? It says, a gambler must throw a 6 with a single dice to win a prize. Find the probability that he wins at his third attempt. So I think it definitely means to say that he wins the first time on his third attempt. And in order for him to do that, he must lose the first 2 times to win on his third attempt. Okay, now some people might say, oh, it's 1/6, but that's his third attempt. He must have failed the first 2 attempts. So it's the probability of him losing, and then winning. The probability that he wins is 1 out of 6, so the probability that he loses is 5 out of 6. Times 5 out of 6, because he needs to lose the second one as well, and then times the 1 out of 6, and that works out as 25 over 216. Okay, so if gambler needs to throw a 6 to win, find the probability that he wins, it's meant to say for the first time at his third attempt. That means he loses the first 2 and he wins the third one. You can't just say 1 out of 6 because you have to take into consideration the first 2 as well. Okay, there's going to be a good few questions like that. Next question. Probability of 3 pupils, so it's 3 pupils. Sorry, I'll just rub it out here. 3 pupils A, B, C. So this one catches people out a good bit. The second two parts. Sorry. So 3 pupils A, B, and C have birthdays in the same week. Find the probability that they all fall on Monday. So that's a nice easy one. The probability that A is on a Monday is 1 out of 7. Obviously, there's 7 days. The probability that B has it on a Monday is 1 out of 7. B is not affected by A, they're independent. And probability C has it on Monday is obviously 1 out of 7. And for all those three things happen, Monday and Monday and Monday, the multiplication rule. So it's 1 over 343. 343. Okay, that's not too bad. The next one is the ones that catch out people, the next 2 questions. The probability that they all have it on the same day. Probability that they all have it on the same day. If we take A definitely has to have his birthday on one of the days. So the probability that A has a birthday on one of the days is equal to 1. A has to have his birthday on one of the days. So we just, the first person, it could have been A, B, or C. The first person, they definitely have a day. So they definitely have a birthday on one of the days. The next one is the probability of B on same day as A. Now again, this could have been any of the days, but now that you've chosen a day, the probability that B is on that same day is 1 over 7, and the probability of C on that same day, because it's not affected by any of the 2, is also 1 out of 7. So the probability of that is 1 times 1 out of 7 times 1 out of 7, which is 1 over 49. So there's a 1 over 49 chance that they have it all on the same day. And it's similar to the last part. Probability that they fall on different days. Again, the probability, will go A, because it's alphabetical order, has a birthday on one of the days, equals 1 again. A has to have his birthday on one of the days. It tells you that he has his birthday on that week, so it's one of the days. Now, the probability that B is a different day is equal to, he can't have it on the same day as A. A has his birthday on 1 out of the 7 days, so there's 6 out of the 7 days that B can have his birthday on. And the probability that C is a different day to both of those, if A has his birthday on one day and B has his birthday on another day, there's only 5 other days that C can have his birthday on for it to be a different day, so it's 5 out of 7. So the probability of different days is equal to 1 times 6 out of 7 times 5 out of 7, which is equal to 30 out of 49. So it's the second two parts of that that really people struggle with, because they leave out this 1. Okay, so remember, for the first person, you just pick one of the days. It has to be one of the days. So that's why it's a probability of 1. They definitely have their birthday on one of the days. That's the little trick there. Okay, I'll get to try a few questions. Some of those types of questions will pop up in the questions I'm going to give as well.